Have you ever wished you could write code with the beautiful simplicity of Python, but have it run with the raw, down-to-the-metal speed of C? I mean, that's kind of the developer's dream, right? Well, a fascinating new tool called PythoC is making a serious attempt at turning that dream into a reality. So, let's dive in and see what it's all about. All right, here's our game plan. We're going to start by looking at the deep connection Python and C have always had. Then we'll introduce the new challenger, PythoC, and see how it literally turns Python into C with a hands-on example. And we'll wrap up by exploring its secret weapons and what all this could mean for the future of programming.
So, to really wrap our heads around what PythoC is doing, we first need to get something straight. Python and C are not strangers. Not at all. In fact, their relationship is absolutely fundamental to how Python even works.
Yeah, it might sound a little wild, but the version of Python you're probably using right now, CPython, is actually a C program under the hood. Seriously, this connection goes way back. Think about all those high-performance libraries you use, like NumPy. A lot of the time, they're just really nice Python wrappers around incredibly fast C code. The two have always gone hand in hand. And that right there, that's the classic trade-off, isn't it? We love Python because it's so easy to read and write. But when you need that raw, unadulterated speed, or you need to talk directly to the hardware, C is still the king. The big challenge for years has been, how do we get the best of both worlds? For ages, the go-to answer has been a tool called Python. It lets you write code that looks a lot like Python, but it gets compiled into a C extension that your main Python program can then use for a massive speed boost. Now, remember that phrase, it creates extensions for Python. That's going to be important. And that brings us to the new kid on the block, PythoC. This isn't just another flavor of Python. No, it's based on a completely different philosophy for how these two languages should work together.
Now this quote, right here from PythonOps creators, this says it all. This is their mission statement. It's not about making Python faster. It's about using Python's power and elegance to generate pure, high-performance C code.
So here's the crucial difference. Python makes modules to be used by a Python program. PythoC's main goal is to create a standalone executable, a C program that can run all by itself, completely independent of Python.
Okay, that all sounds great in theory. But what does it actually look like? Let's walk through a super simple example and watch Python code literally transform into a C program. So check this out. It looks like a normal Python add function, right? But there are two bits of magic here. First, that @compile thing on top, that's a decorator. And it's basically a flag telling PythoC, hey, take this function and turn it into C. Second, notice the i32 type hint. We're not using Python's normal flexible integers. We're being specific, telling it to use a native 32-bit integer for maximum C-like speed. And it gets better. By adding a standard main function, yep, just like you would in C, and then calling compile to executable at the end, the whole nature of this script changes. It's not just a Python script anymore. It has become a blueprint, a factory for building a complete standalone C program. So the whole workflow is just incredibly direct. You write your logic in clean, familiar Python, you run that Python script one time, and poof, out pops a native compiled C program. You're using Python as your personal C factory, no complex build systems required. But PythoC is way more than just a simple translator. It has a couple of tricks up its sleeve, a couple of what I'd call secret weapons that make it really, really powerful. First off, it does a fantastic job letting you write C concepts using Python syntax. You can create structs and unions just by decorating a class. You can work with pointers using PTR. You can even use Python's modern match/case syntax to generate efficient C switch statements. It just makes writing C feel much more approachable and, well, Pythonic. Now for its first real superpower, compile time code generation. Take a look at this makePoint function. This is a regular Python function that acts as a template. The key is, it doesn't run when your final C program runs. It runs when you execute the Python script, and its job is to build C code for you. And here's the payoff. By calling that one Python template function with different types, like an integer and a float, PythoC generates multiple, highly optimized, type-specialized versions of the C code. You're using Python's dynamic power to write static, fast C code. That is something you just can't do easily in standard C. PythoC's other secret weapon is that it takes on C's most infamous problem, memory safety. But instead of leaving it all up to you, It introduces some clever, type-based safety nets that work before you even run the code.
It's got two main features here. Linear types basically ensure that if you allocate memory, you must deallocate it exactly once. The program literally won't compile otherwise, which helps prevent a whole class of bugs. Then there are refinement types, which let you bake rules into your types, like defining a pointer that is guaranteed never to be null. This catches entire categories of bugs before they ever happen.
So with all this power, where does PythoC actually fit in? Is it here to kill Python? Well, not exactly. It's really about choosing the right tool for the job. And this table just sums it up perfectly. If your goal is to speed up a specific part of an existing Python app, Python is still your tool. It's the king of integration. But if your goal is to build a brand new, high-performance C program from the ground up, and you just want to use a much nicer language to do it, that's the sweet spot for PythoC. And the project is still pretty young. You can totally imagine a future where a new feature, maybe something like an @cache decorator, could let PythoC get some of that tighter Python integration, blurring the lines and making it even more versatile.
Which leads us with a really fascinating question. We've always thought of C as this low-level, manual, and kind of dangerous language. But tools like PythoC suggest a totally different future, one where we use the power and safety of high-level languages to build the fast, low-level code we need. Is this the next evolution in programming? It's definitely something to think about.